So up next, we've got a 3-part special showcase where you'll hear from product and engineering folks from Datadog, IKEA Retail, and Meta, and you're going to learn how they use plugins at their orgs. And so to kick things off, we've got Derek and Jenil, 2 designers that are building tooling at Datadog to make designing a highly technical product a lot easier. So let's give it up for Derek and Jenil.
Hi, my name is Derek Howles. I'm super excited to be here and talk to all of you today. I'm a staff product designer at Datadog in New York City. I've been there for just about 8 years now, and I'm one of the co-founders of our design system, which we'll talk a lot about today, and of our design ops team.
Hey folks, I'm Jenil Gogari. I also work alongside Derek at Datadog in New York. I have been at Datadog exactly 5 years this week actually. And apart from working on the design system, I also lead the design tooling and infrastructure efforts at Datadog.
Cool. So, before we go into our design system, any of the tooling that we've built for it, it'd probably be helpful to know what Datadog is. Maybe some of you have heard of it, probably some of you haven't. Basically, at the broadest level, we're a SaaS platform that companies use to monitor and troubleshoot their systems that are running in the cloud. So this takes a lot of forms. For example, are your servers and other cloud computing resources, working correctly? Are they going down for some reason? If so, what might be happening? Do you have security vulnerabilities in your systems? Is your website experiencing slow performance? Are your customers getting errors in a checkout flow when they're trying to buy something from your app? All sorts of things like that. You can send tons of different types of data to Datadog. You can visualize it in lots of different ways, and you can make connections. You can follow connections via lots of different pathways in our UI as you're investigating, what might be going on and what might be going wrong with your systems and your software. And most importantly, all of that data has to be easy to read and has to be easy to understand. And especially, from a design standpoint, that can be a tricky line, to walk sometimes, considering that it's a technical product that deals with technical information that's used primarily, not exclusively, but primarily by technical people. So, as you might imagine, that technical nature is embedded pretty deeply in and really shaped the creation of and the foundation of Druids, which is our design system. So Druids, as you can see here, hopefully stands for Datadog Reusable User Interface Design System, which is a bit of a sort of a mouthful and a redundant acronym, but we sort of came up with it backwards. We had the logo first, came up with the name. I don't know, there's probably a lesson there somehow. I don't know what it is exactly. But it's also probably not surprising that of the 2 core user types, internally for our design system, designers and front-end engineers, the tooling and the documentation for Druids sort of historically has been more robust for engineers. From the beginning, we built a lot of powerful features geared toward them. Yeah. And things that really sort of help their workflows in a lot of different ways. Mm-hmm. Some of that stuff includes, live playgrounds for every component that uses, copy and pastable production code that you can edit, right in the docs in a sort of sandbox playground type thing. You can change values, you can change props, you can see, actually what the real effect on the component will be, and you can copy and paste that and use that code in production, and you can share it and things like that. Things like, for every component, a table that lists all the props and all the potential values for those props and descriptions for those, and that's generated automatically from annotated source code. Links to open, that component or that pattern in GitHub or in VS Code, and have those links embedded right there in the documentation. And incidentally, a lot of this stuff is stuff that Figma talked about in the keynote in a certain way, in the dev mode that they're releasing. And so that's kind of a cool connection there, I guess. And then, next slide. There we go. Other things like JS doc comments that show component descriptions and link back to our doc site, from right inside a developer's, code editor or IDE. Basically, we've done all these kinds of things that cater to different points in a front-end engineer's development lifecycle. And given the technical nature of Datadog, our design system has a lot of complex components, a lot of things that let customers do really specific things inside of our UI, things that are particularly tailored to Datadog and to a piece of software or a type of software like Datadog. And these kinds of internal tools make it really easy for our engineers to figure out how they can use what they need to use and then how to build and iterate quickly without compromising on the end user experience. But you're probably asking, what about designers, right? We're at Config, after all. Jenil and I are both designers. Why are we talking so far only about front-end engineers? And basically, it's to highlight the fact that we've done a really good job of meeting front-end engineers where they are in their process. We've done that really well for a really long time. And we have wanted to and have started to translate that same approach into improving the ways designers can work with our design tools, with our design system, and to build the Datadog UI and platform. And so, just like many of you at this conference, I imagine, the majority of designers at Datadog spend more time in Figma than they do anywhere else. So meeting designers where they are means giving them tools in Figma to help with the parts of the design process that are especially important for a technical platform like Datadog. So for us, one of the most important parts of that is designing with real data. So now I want to hand it over to Jenil to talk more specifically about a few of the things that we've built in that regard.
Cool. Thanks, Derek. Like you said, designing with real data is hugely important for us. The idea of real data takes different forms, and one of those forms is strings of text. For example, servers running in the cloud, like AWS or Google Cloud, are tagged with a lot of pieces of metadata. These things can look like I-17 digits, but these 17 digits actually matter a lot for engineers and users of Datadog. This is what distinguishes one server from the other, and the user needs to be able to scan them very easily. Next. Sorry, previous slide. Can we go back one slide? Once more. Yes.
There we go.
Or file names in a web request. They are inherently long, but it's important for the user to be able to easily be able to scan them row by row. Next. Or names of microservice operations, as you see in this flame graph, which shows a request flowing through your code, and the user needs to be able to see how it's flowing through their entire software stack. Or really any string of text related to code or software that appears in the UI. Basically, the Datadog platform encompasses many different types of data, each of which has a special display consideration. These things might seem like edge cases in other situations, but they're not edge cases in the case of Datadog. To help with this, we built a plugin called Bits of Content. Relevant fact, the dog in the Datadog logo is named Bits. It pulls, quote unquote, real fake data from an API that is connected to an account that is used for demoing Datadog. The data is realistic in shape, but does not belong to any customer, which means it is not sensitive or risky to share around. Another example here is, for example, if you're designing a table, you can account for long text strings when laying out columns. You can easily see where your design may break or where you're at the risk of hiding important information and where you need to allocate more space. This can help you make decisions like whether you need to add an ellipsis at the beginning of a string or end of a string, and so on and so forth. And since we pull all of these things from different types of content and different data types, designers working on the entire Datadog platform are able to use this plugin. In this instance, as you can see, we are using serverless function names to populate our serverless page. Another example is integrations. Integrations are what make Datadog Datadog. Users can send and track data using more than 450 third-party integrations that work with the Datadog platform. These integrations can appear as logos in all and any parts of the Datadog platform. And logos are also a part of bits of content. Our team, the design system team, maintains a repository in code that is the source of truth for all of these integration logos. The plugin is connected to this repo and allows the designers to pull these logos into Figma with just one click. And as you can see, they're available in different aspect ratios, as well as they support both dark mode and light mode. To put things in perspective, that's around 450 logos times 3 sizes per logo times 2 variants or themes, which if you add them, it's like 2,700 variants that we'd otherwise have to maintain in Figma, but the plugin takes care of them all automatically. And since bits of content is connected to our code base, whenever we add a new plugin, whenever we add a new logo, the plugin automatically pulls it into Figma via an API call to an internal endpoint. That means we are mirroring things in Figma the same way we do it in code. And again, we're bringing it into designers' workflow in a much low-friction way. Another major area where we've done plugin development is dark mode. Because of the practical benefits of dark mode, it is especially important for a software like Datadog. For example, an engineer can be paged in the middle of the night because of an issue in their systems, and they could be opening their laptop at 3 a.m. At that point, dark mode is godsend. Support for dark mode is, or rather platform-wide theming, is built into the system with using a robust set of semantic color tokens that are connected with underlying values. It means in most cases, designers and engineers don't even have to worry about dark mode. It just works. And now that Figma just announced variables, we are even more excited to see what we can do with them. Sometimes, however, a designer may need to use a one-off color. Maybe they're working on a new data visualization or a brand new pattern. For example, in this case, everything below the stylized header is using semantic color tokens, but the stylized header itself is using some custom colors and illustrations. So here, the designer needs to make sure that their header works in dark mode. For cases like this, we've built a plugin called Dark Modder. The plugin swaps dark mode values for each semantic color token so that the designer can check whether their one-off colors work in the grand scheme of things and fine-tune if necessary. As you can see over here, some big changes in the header are called for, like the gradient needs to be inverted in some way, and the illustration probably needs a dark mode variant as well. Maybe something like this would be more appropriate. In general, the idea is that we want to meet designers where they are by building stress testing into the Figma design process. So designers can account for these considerations in a much more fundamental way. It's stress testing that isn't stressful.
Exactly. So thanks for showing all of that. Hopefully this gives an interesting glimpse into a few of the ways that we're using Figma to bring concepts like designing with real data and mirroring what we can do in code into designers' workflows. And like we saw this morning at the keynote, I think we're going to be able to do that even more robustly and sort of even more natively in Figma, and it's going to be able to sort of go the other way too, which is really exciting. But maybe, and maybe this all goes without saying, but I think it's important to say anyway. It's something that we talk about internally a lot, and I think it's something that anybody here can sort of take away or remind themselves about this. we're not doing all of this just for the sake of awesome tooling. It's really fun to create all this stuff. Helping designers and engineers, create designs and prototypes that are more realistic is great. But realism is just a means to an end. I think it's really an important thing to always remind ourselves about. The end goal of realistic designs and of having a close connection, between design and code is to keep our focus on showing Datadog customers, showing our end users what matters to them, and doing it in a way that helps them understand their systems even better. That's the point of doing all of this. Maybe it's obvious, but it's why we invest, so heavily in all of this stuff. So that's all from us. We'll be around to chat more if anybody has questions. If you want to check out the doc site for our Druids design system, you can use the QR code here. Hopefully that works. If not, it's just druids, druids.datadoghq.com. And it's not open source, but a lot of this stuff is publicly visible, and you can check it out. And like I said, come find us if you have questions. And that's it from us. Thank you.
Cool. Wow, props to the Datadog team for walking us through that. I really love that the announcement of variables today is just going to unlock even more power with their plugins. Next, we've got JF from Meta. JF builds massive internal tools there, and they're ones that are being used by the tons of designers at scale. I'm excited for him to walk through his work. So please give JF a warm welcome to the stage.
Hi, everyone. My name is JF, and I'm a software engineer at Meta. For the past 4 years, I've been on the design tools team, supporting designers by building custom plugins. Today, I'm so excited to give you a look behind the curtain on how one of the largest tech companies in the world builds custom plugins for scale. Today, my talk is split into 3 parts. First, I'll explain why it's worth it to invest and build custom plugins. Then I'll showcase some of the plugins that we built internally at Meta. And finally, I'll give you some tips and tricks to help you scale your plugins. First, you may be asking, why bother build custom plugins? After all, Figma already has free community plugins that anyone can use to enhance your design workflows. From color contrast checkers to mockup plugins, there's an endless number of them, thanks in part to some of the people in this room. But exceptional design goes far beyond the visible pixels on the screen. For a company the size of Meta, the standard of high quality means to integrate your visual design with other core pillars of the company, like engineering, compliance, and privacy. Custom plugins allow designers to easily build with these partners in mind by integrating company-specific data directly into your designs. Another use case for custom plugins is to enable company-specific workflows. For example, a designer may want to copy their Figma designs to Origami. Origami is a high-fidelity prototyping tool built in-house at Meta. And while the file types for these 2 tools are not natively compatible, custom plugins allow designers to make the transition at a click of a button. And finally, custom plugins allow us to push the boundaries of design tools. The mission of my team is to empower designers to build world-class products. And so we're always exploring new ideas in ways to push Figma to new limits to see what we can offer our designers to build world-class experiences. So now that we've talked through why custom plugins can be incredibly valuable for your organization, I'll show you some of the plugins that we built internally at Meta. First is our components plugin. I think we can all agree that components are some of the most important building blocks of Figma designs. But Meta has over 10,000 components across hundreds of teams. It can be incredibly difficult for designers to find the right components. The components plugin allows designers to find components that are relevant to them. The plugin organizes and ranks components to promote usage of high-quality ones. Designers can also find key information for each component, like which team owns it, link to its spec, and code availability information. Instead of looking for all of this information ad hoc, designers benefit from a customized user experience that provides all the necessary information in one place. The next plugin that I'd like to show you is our data plugin. But before I show you this plugin, I want you to put yourself in the shoes of a designer creating an exciting new product. You want to design this product in a way that represents Meta's diverse user base. Now imagine that it's your job to hand-select profile pictures and names to add to your mockups to represent 3.8 billion users. Even with the best intentions, it's a near impossible task and invariably introduces the risk of implicit bias. The data plugin allows designers to insert profile pictures and names from Meta's diverse data set. Every picture in the data set was sourced directly by Meta. Every individual featured in the pictures signed a legal contract granting Meta permission to use their pictures for commercial use. In this example, we're using the plugin to populate a facepal component. And so as you can see, not only is it easy for designers to uphold the standards of Meta's diversity goals, but it also allows them to do it in a way that considers the privacy and compliance requirements. Finally, I want to share our quality check plugin. The goal of every design team is to build high-quality products that users love. But as we discussed earlier, high quality can mean many things. In Figma, it's both visible elements, like sufficient color contrast and proper spelling, but it's also about invisible elements, like proper usage of color styles for efficient engineering handoff. Meta hires some of the best designers in the world, but they are human, and even the best of the best make mistakes from time to time. Issues that are found in production can be very expensive to fix. It can result in poor user experience, require significant rework, and at worst, product downtime, all of which we want to avoid. And so at Meta, we have a bias to shift left on product quality. An issue found in the design phase is much cheaper and easier to fix. So we wanted to empower our designers to identify and correct these issues earlier. The quality check plugin automatically checks your designs for things that do not meet Meta standards. It alerts designers that issues have been found and provides recommendations for how to fix them. So in this example, a designer accidentally hard-coded a color. And even though the color visibly looks correct, an engineer cannot easily build off the design spec, which slows down the development process. With one click of a button, a designer can use the plugin to apply the appropriate color style. Every tool that empowers designers to increase the quality of their design increases the efficiency and velocity of product development. So now that you've seen some of Meta's plugins at work, I want to share some more background in terms of how we build plugins. Today, Meta has an engineering team supporting a dozen custom plugins. I'll share some of the tips and tricks that we learned along the way that helped us scale. First is packaging. Supporting a dozen plugins can create a lot of chaos. And so we decided to bundle all of our plugins into one surface that we call Design Kit. After opening Design Kit, every plugin is accessible from a tab. This creates a unified and seamless user experience, reducing friction and promoting interactions between the plugins. Another added benefit of this architecture is that the engineering team can reuse plugin infrastructure, reducing work to create new plugins. While packaging may seem like a small thing, creating a convenient and seamless user experience for designers is key to driving adoption of new plugins. The next challenge that we faced at Meta is our number of design systems. Meta maintains some of the biggest design systems in the world for some of the largest products. Instead of creating a custom plugin for each design system, we created our plugins to be design system agnostic. This means that designers can select the design system they want to use and only see information that's relevant to them. The way we pulled this off is by creating a design system registry that stores information for each design system. Our tools, including DesignKit, then stack on top of this registry for a customized user experience. And finally, I want to share how Meta scales its development process. This can be particularly helpful if you have multiple contributors working on the same plugin. Now, we have an engineering team supporting a dozen plugins. And while that creates a lot of firepower, it also creates challenges for effective collaboration. For us, those challenges were made worse by Figma's release process that's manual. It created confusion over who owned the releases and when those releases should occur. To solve this, we created a continuous delivery framework that removed the need for the manual publish step. By removing the manual publish step and automating the releases, we were able to remove some of the bottlenecks that allowed us to ship updates more often. As an added benefit, this framework allows us to build using Meta's standard tooling and processes. So this is a demo of our continuous delivery framework. And what I want you to take away is that modifying the source code automatically results in plugin changes in Figma without having to publish. So here I have an example plugin, and I can insert Hello World on the canvas. Then I go to GitHub and modify some of the source code. After committing the changes and waiting just a few seconds, the changes are already live in Figma. Here I run the same plugin, and the updates are live. So this ability to release more often increased the agility and impact of our engineering team. In summary, Figma is such a powerful tool. It's enabled Meta to maintain best-in-class design standards. And hopefully this talk helped you see how custom plugins can enhance the efficiency and impact of your design teams as your company scales. Thank you so much.
Thanks again, JF. Really loved hearing all those tips from like a plugin building pro. Lastly, we've got Elliot, who's flown all the way from Amsterdam, here to share how building plugins at IKEA helps designers quickly build out UI with real data. So let's give it up for Elliot.
Thank you. Hey everyone, my name is Elliot, designer by IKEA, designing the online shopping experience. And today I wanted to share with you the story of how my quest for efficiency led to the creation of a Figma plugin that automates IKEA product data into our design process. Now, when I mention IKEA, most of you probably have a good idea of what it represents. But you may not be aware of its humble beginnings as a small mail order company in rural Sweden. Over time, it has grown into a global furnishing brand known for its affordability, design, and comfort. Despite our progress, our core vision remains the same: to create a better everyday life for many people. Over the past decade, IKEA has been undergoing a significant digital transformation. In addition to physical store visits, there has been a notable increase in online engagement from our customers. Currently, nearly 80% of all shopping journeys with IKEA begin online. In 2022, online sales represented 25% of the total, a significant rise from the pre-pandemic figure of 7%. As we progress with our digital transformation, our focus remains on creating a seamless omni-channel experience, continuously improving online support, and introducing new digital services to cater to our customers' evolving needs. Now, as a product designer on the listing team responsible for search, my objective is to assist customers in discovering their ideal solution among our extensive range of over 1 million product combinations. Given that 26% of all online IKEA shopping journeys begin with a search, our team has the potential to greatly influence the overall IKEA shopping experience. As a designer, my work involves constant iterations on design variations for products. To test these designs in real-life scenarios and user studies, it's crucial to populate them with authentic data. However, manually adding text and images can be incredibly time-consuming and tedious. And well, I must admit, I happen to be a bit of a lazy person, which is why I developed the Placera plugin. Placera is Swedish, and it means literally to place or to fill in. Invented by my colleague Christian, thank you. That connects to our internal product database and retrieves the necessary data and images for us and places it into our designs. By using Figma's plugin API and our internal APIs, we can now populate our designs with real data in a couple of clicks. This not only saves us time and effort, but also ensures that our designs accurately represent real-world scenarios. To the plugin, our design team is using the exact same data set as our back-end and front-end developers. This allows us to talk about the product data in the same language, which helps closing the gap between design and development even further. Next to that, because the plugin uses the same API that's being used in the front end, so on the web shop, the plugin benefits from all the future improvements that our backend teams built in our search box and our search results APIs. Let me show you a quick demo. So the Placera UI is very simple and contains a result list and a search box. Right now, we want to fill a design with products from the new Marimekko collection, which was released in spring 2023. Next, select a pre-made product card component, which contains the product name, product description, the price, and the product image. With this design selected, I'm going to click Fill in the plugin, and then you see that the design gets filled with the product data, first product of the search result. Next, we're going to duplicate this component to create a full list and fill all of those instances again to get a full list of products. Easy as that. But what if I'd like to see how this looks like in a different language? The Placera plugin allows me to easily create or select a different market. And then with my design still selected, click the Fill button again. And now you see that the design gets filled with Japanese characters. And you even get localized price units. So that's very convenient. Now, imagine you want to highlight one product on top of your product list in a different way. So let's create a new design for that. I quickly draw a rectangle with a nice overlay and the product name, product description, of course. Now, the Placera plugin allows me to dig into any product detail and show all of the product data that is available to me. So here we have the article number, the product name again, product description, and so on and so on. But right now, I'm interested in an in situ picture of this Bastoa site table. So I'm going to select this rectangle again where I want to have my image. I'm going to pick and choose a 900 pixel image, and that gets filled with one click of a button. I'm going to do the same with the product name, the product description. And I have a new design with real data. I'm going to drag this into my product list, select all the child instances again, and fill everything with product data again to get a new list with products. Now I have a new design template that I can easily reuse and fill it with other products. For example, you name it, dressers. There you go. We can take this a step further. Lastly, I'd like to show how we're going to search for dinnerware on the IKEA website. I said dinnerware? Yeah, thank you. But I only want to have blue, green, and turquoise dinnerware. And I want them to be made out of ceramic. So I'm going to select that. Now, to get this selection of products into my design, I just need to copy the URL of this product listing page with the filters applied head over to my plugin again, paste that URL in the search box, and the plugin automatically detects the page type. It's the product listing page, the selected market and language, the category, which is for dinnerware, and it recognizes that it has 2 filters applied. Now, when I get the results, you'll see that the plugin retrieves the exact same product set as I would see on the IKEA website. Now, with my design still selected, I'm going to make an even more custom selection of nice bowls, blue, green, turquoise, and ceramic. And now I have the products in my designs that I exactly wanted to have. So that's a plugin in a nutshell. Thank you. So it all began last year, right before summer of 2022. Then I started tinkering with the idea to build a Figma plugin at IKEA to tackle the exact problem that I just illustrated. Midsummer, which is actually happening this week as well, is a very quiet period at the IKEA office, so the perfect time to start learning how to build a plugin. I started watching this great series of videos where Sophia from Figma explained the basics of building a Figma plugin. This series of videos really helped me understand the gist of plugin development. And it gave an example of how to send and receive data from and to a third-party API. And this was exactly what I needed for my plugin idea. Of course, I didn't start from scratch. And since I've already had basic React development experience, I chose to start off with the Figma plugin React template by Neersky. And I took some inspiration of the naming convention used in Dave's Google Sheets sync plugin. The plugin has had 20 releases since the summer of 2022, and over 100 design colleagues at IKEA have been using it. So that's pretty nice. And from the outset, my approach was to frequently ship updates, learn quickly, and improve steadily. And I designed this tool specifically for my direct design colleagues, which provided a safe environment to deploy a product that was not fully feature complete, but could be improved upon as we progressed. Yeah, let's wait a bit. Yeah. I initially created this plugin to solve a personal pain point and automate a tedious task. However, I quickly realized that it could be helpful for other design colleagues who were facing different scenarios. It was pretty cool to see the plugin serve a broader purpose and help fellow designers streamline their workflow. So, for example, the fulfillment team leveraged my Figma plugin to streamline their DOI design process for their returns tool. The returns tool is used by our store coworkers. And the store team used the Placera plugin to populate the designs of their in-store screens. And these in-store screens are used by our customers to explore the full range while at the IKEA store, or find that one item to pick up at the self-service warehouse. Also, this plugin helped the in-store team to quickly test out new designs, and the naming convention of their layers helps them communicate with their devs who are using the same data references in their front-end code. Overall, building this plugin was not just about solving a problem for lazy me, but it was also a learning experience. As someone who has a background in UX design, I wanted to challenge myself to learn more about front-end development, specifically JavaScript and React. So to summarize, building this plugin helped me gain hands-on experience in advanced front-end development concepts and best practices, and it learned me how to integrate with Figma's plugin API and our internal APIs to retrieve that data and images. Secondly, through building this plugin, I connected with other design teams and learned about their workflows to better understand their needs and provide these features accordingly. And lastly, I learned how to manage a product in an agile way. I learned that the key to a successful product is to involve users early and often, so I implemented a strategy of shipping often and learning fast to validate the most important features for them and prioritize those features accordingly. So all in all, it was an amazing learning experience for me, and I'm very grateful for getting the opportunity at IKEA to have developed my skills and knowledge in such a hands-on way. So coming back to the title of my talk, I'd say laziness is smart. So embracing laziness is a very powerful motivation to delve into plugin development, empowering you to create your own custom Figma plugins. Thank you for listening to my presentation, and I hope this has inspired you to leverage Figma's plugin API to improve your design workflows too. Thank you.